In the name of God, this is Shayan Ramazi, the presenter of this paper, Averting Mode Collapse for Generative Zero-Shell Learning. What is zero-shell learning? Standard supervised learning methods require labeled data in the training phase. What happens if we do not have labeled data? Zero-shell learning is an emerging learning paradigm that addresses the problem of recognizing unseen classes during training phase. In other words, we try to teach computers to recognize something they have not seen before. According to the explanation of the previous slide, the classes will be divided into categories: seen and unseen classes. The seen classes are the classes that will be present in the training phase, but the unseen classes are not present in this phase and will only be present in the test phase. Each class has three main components. We know two components: feature and label. But there is another component called attribute. This component is actually a description close to human language for each class. According to my explanations, we can define the ZSL task in such a way that we have the features and attributes of unseen classes, and we would like to obtain the label of these classes. There is a more challenging version of zero-shell learning, which is called generalized zero-shell learning, or JZSL, in which the seen classes are present also in the test phase. Also, it is worth mentioning here that the seen and unseen classes overlap in the attribute space, and actually ZSL task is done using this overlap. ZSL has generally two approaches: classifier-based and instance-based. In the classifier-based approach, we seek to train a model that has the ability to classify unseen classes directly. But in the instance-based approach, which our paper is based on this approach, we seek to obtain samples of unseen classes. In our study, we have used one of the generative models, GAN, or Generative Adversarial Networks. Generative Adversarial Networks, or GANs. The GAN's core components are its generator and discriminator, producing fake data that the discriminator is unable to discriminate between. That and real data is the objective of the generator. On the other hand, distinguishing fake data from real data is the discriminator's objective. Training of GAN is done by the contest between the generator and the discriminator to produce fake data identical to real data. The generator network only receives a noise vector as an input. If we want our network to be able to generate data from a specific class, in addition to the noise, we give the label vector as an input to the model. This model is called conditional GAN or CGAN. What is WGAN or Wasserstein GAN? The Wasserstein GAN is the GAN variant that uses the Wasserstein distance rather than the JS divergence to measure the difference between the fake data and real data distribution. The discriminator part of WGAN is called predict because it assigns a number to each generated sample, indicating the similarity between that sample and real samples. What is generative zero-shell learning? In this research, we have used a conditional Wasserstein GAN. We train this GAN with features of seen classes and their attributes. In the training phase, According to the overlap of the attributes of seen classes and unseen classes, conditional Wasserstein will be able to generate features from unseen classes. This data will be used to train a classifier. Also, we clearly turn the ZSL task into a supervised learning task. What is ranking scientific features? In this paper, we rank the generated feature based on the points assigned by the critic, and we use this score effectively in updating the weights of generator. In fact, we remove the low scoring part of data that is generated by generator. What is mode collapse? Mode collapse is one of the controversial issues of GAN. Usually, we want our GAN to produce a wide variety of outputs. We want, for example, a different phase for every random input to our phase generator. However, if a generator produces an especially plausible output, the generator may learn to produce only that output. In fact, the generator is always trying to find the one output that seems most plausible to the discriminator. If there is a little diversity in the output and some of them are almost identical, then there is likely mode collapse. Anti-mode collapse regularization term. Remember that we sample two random variables z1 and z2. We generate two fake feature vectors x1 hat and x2 hat from them. When z1 and z2 are closer, x1 hat and x2 hat more likely to be collapsed into the same mode. To mitigate this, the anti-mode collapse is defined regularization term as below. We can observe that this term amplifies the dissimilarity of two fake feature vectors when the latent codes generating them are of high similarity. Feature generating networks for zero-shot learning. One of the papers that used GAN to generate data is this paper. In addition to using a WGAN, this paper uses a pre-trained classifier which gives the generated feature a better distinguishing capability. In fact, before the GAN training, the classifier is trained by the seen classes, and in the GAN training phase, it is used as a regulator term. And also it should noted that the classifier used in this paper is a softmax classifier. In this slide, we will introduce our method, Averting mode collapse for generative zero-shot learning. Many papers have been published inspired by the paper presented in the previous slide. Our paper is one of them. We have used the paper introduced in the previous slide as the basis of our paper. In addition, we have used the regulator term introduced in the previous slides to prevent mode collapse. We have used ranking technique to improve the quality of the GAN outputs, and also we have used another regulator term to reduce the similarity of generated feature from seen and unseen classes. And finally, we have used a decoder that improves the GAN operation to convert generated feature into attributes. After training the GAN, we use it to generate fake features of unseen classes, so we need a classifier to do a classification. This research employs a cascaded classifier. In the first layer of the classifier, we use a softmax classifier. The output of this layer is the possibility of assigning a sample to all classes. So it can be concluded from the output of this layer which samples are more reliable. Outputs with less classification entropy are leveraged as a reliable samples to train the next layer, a softmax classifier. Dataset: animal with attribute. A collection of images representing 50 different animal classes and 85 attributes is called animal with attribute, or AWA. This table contains the detail for the dataset. For feature extraction, a pre-trained ResNet on ImageNet is used. Also, generalized ZSL setting uses 13 testing classes and 27 training classes. Results: in the ZSL configuration, the arithmetic mean of the top 1 accuracy score in each class is considered. On the JZSL setting, the harmonic average is calculated based on the average of the top 1 accuracy. In this table, the JZSL and ZSL settings are used to compare the proposed approach and other methods that use the AWA dataset. The formal results that were published in the papers served as the basis for the results that were reported for the different methods. The results of the proposed method on the AWA dataset in the ZSL and JZSL setting are superior to those achieved by previous methods. Zero-shot learning accuracy is examined in this slide based on a variety of setting options. This information is available in the table. It is inferred that the results of this study improved. At last, let me say thank you for watching this video.